Hey guys, so in this video I'm going over Unit 6, Lesson 8. So to evaluate an expression means to substitute a given value in for a variable and evaluate. So for example, to evaluate the expression 3x, you will need to substitute the value in for the variable, which is 6. So we're going to do 3, and instead of x, we're going to substitute in 6. 3 times 6 gives us 18. So that would be our solution for number 1. Now pause the video and see if you can get the solution of the expression negative 4 times x squared, subtract 7x plus 2 when x is negative 6. Your answer should have been negative 100. So solving sine, cosine, and tangent equations is going to be similar to solving expressions like we just did. So for sine, cosine, and tangent are trigonometry functions. You can just put trig or you can put the whole word. Functions that are related to triangles and angles. We can evaluate angles, legs, or hypotenuses, and I'm going to run out of room, just like any other expression. You can see this by the last few lessons in this unit. When evaluating sine, cosine, or tangent, we must remember that the value we substitute into the expression represents an angle. We have to check our mode to make sure the calculator knows what measure we are using. So in your calculator, it is either radian or degree. And for now, in this course, we are only dealing with degree. And if you do not remember how to put your calculator into degree mode, or you are using Desmos and you want to know how to change it to degree mode, please check out the other videos prior to this one. Always use degree mode, like I kind of just said. And if you're using an actual graphing calculator, to select degree mode, it should be highlighted. For some angles, the value will be negative. This means that there is no triangle created at this value. We'll go over a few of them like this. There we are. Okay. So let's go over a few. We've done some of these, I believe it was in lesson 3 and 4. So I'm going to do 4, 5, and 6. And then we can pause the video and do 1, 2, and 3. So for number 4, we have cosine of 45 degrees. Well, we're going to go into our calculator and find this answer. So because I am on my iPad, I am going to do this on Desmos. So once you're in Desmos, you go to the top right corner where the little settings is, and you select degrees. And then for number 4, we had cosine. So I'm going to select the little keyboard at the bottom. Okay, I can't do both, that's fine. To get cosine, I'm going to go to functions. And under trig, I've got sine, cosine, tangent, and I also have the inverses right beside them. So I'm going to select cosine, and I've got cosine of 45. Well, if you look, that is our answer for number 4. So it does not tell us where to round, so I'm going to keep 4 decimal places. So 0.7071. So that would be my answer for number 4. Number 5. Number 5, we have sine of 30. So I'm going to go to my Desmos. Can click into another little box off to the side. I'm going to hit functions again. I'm going to hit sine of 30. And if you want to, every single time, you can always go to the settings and make sure that degree is selected as the node. So sine of 30 is 0.5 or half. So that is going to be our answer. Now, 6 is the trick. So simply, if you put tangent of 90 into the calculator, tan of 90, it says undefined. So you can simply just put undefined or not possible due to that. Now, the reason why it is not possible is due to tangent of 90. Well, tan equals opposite over adjacent, correct? Well, if we're looking at 90-degree angle, that opposite side is actually the hypotenuse and not the opposite side. So it's not possible because it's pointing us to looking at the 90-degree angle versus one of the other angles in the triangle. So number 6 would be not possible. So if you will, pause the video and attempt number 1, 2, and 3. Number 1, you should have gotten 0.788. Number 2, you should have gotten 0.5299. And number 3, you should have gotten negative 4.01078. So, solving equations. To solve an equation means to simplify all the operations to get the variable by itself. To undo an operation, it means to use the inverse operation. The inverse operation of addition, hopefully you know, is subtraction. The inverse operation of multiplication, again, hopefully you know these, is division. And the inverse operation of squaring is taking the square root. So for example, we have these equations, and I'm going to write this kind of small so I can fit it underneath. For number 1, our goal is to get x by itself. So we're going to do the opposite of PEMDAS. So instead of going forward or going left to right, we're actually going to be going right to left. So if there's any addition or subtraction on the side of the equal sign with the variable, we've got to undo it first. So we're going to subtract 5 from both sides. We're left with 3x equals 9. Then we're going to do multiplication and division. So there is multiplication with the variable still. So we got to do the inverse operation of multiplication, which is division. 3's cancel out. X equals 9 over 3, or 9 divided by 3, which is 3. And that would be our answer for number 1. So pause your video, or pause this video, and attempt number 2. Number 2, you should have gotten 6. If you need to pause the video and look at my work, please do so now. So solving sine, cosine, and tangent equations. We can solve equations by involving sine, cosine, and tangent, just like any other equation. Inverse operation of sine is inverse sine. It has that little -1 in the exponent. Cosine, inverse operation, is inverse cosine. And of tangent is inverse tangent. Now, for the last bullet point, I just need you to mark it out. And I simply want you to put, for some values, there will not be solutions. So let's go through solving some of these. So for number 1, always, just like any other equation that we're given, we want our x by itself. Now, there is not multiplication in between sine and x. It is a little bit more complicated than just multiplication in between. So to get rid of sine, our inverse operation of sine is inverse sine. So we're going to take the inverse sine, which is sine, that little -1, and that gets rid of the sine. And we're just left with x on the left side. Well, what we do on one side, we have to do to the other. So inverse sine on the right side. So we cannot simplify the inverse sine of 0.6 anymore on our paper. So that is the simplest form at the moment of our right side. Now, with our calculator help, we can simplify it into a single number. So I'm going to use Desmos again. If you want to use your calculator, you can, or the TI free online subscription that you can download. So we've got, still in degree mode, we're going to go to functions again, and we're going to do inverse sine. So that's going to be the second row, first thing. And we've got 0.6. And we are told to express your answer in degrees. There is nothing about rounding. So we're going to do 36.9 degrees. And that would be your answer for number 1. All right, for number 2. So I'm going to show you 2 different ways to do this. So one is exactly what we just did. We want x by itself. We want to get rid of cosine. So we got to do the inverse operation of it. So we got to do cosine, inverse cosine on both sides. Cosines cancel out. You're left with x equals cosine, inverse cosine of 1.5. You're going to put this into your calculator, whichever calculator you're using. Functions, if you're using the Desmos calculator, inverse cosine of 1.5. And because it says undefined, you can just put not possible and move on. Or you can use your knowledge of the trig functions to know that it's not possible using the triangle. So cosine of the angle measurement x, or theta, or whatever variable you want to use to represent your angles, equals adjacent over hypotenuse. So what this is telling us in this problem is that cosine of angle x equals, instead of 1.5, that is the same thing as saying 3 over 2. So that means in the triangle, if we put x up here, our adjacent is 3 and our hypotenuse is 2. Our hypotenuse always has to be the biggest side, or the longest side. So if our leg, or one of our legs, is bigger than our hypotenuse, then it is not a triangle. It's not a proper triangle. Physically, what's going to happen is that these two sides would not meet, and it would not be a closed figure, so it would not be a triangle. It would look kind of like, that's not that one. Hold up. It would look something like that, where the hypotenuse would never be able to touch the bottom leg. So again, the answer for number 2 is not possible. It doesn't matter how you look at it.